Welcome back to another video. Today's plan is to discuss another interesting problem, which you see right on the screen. If 9 to the power x plus 15 to the power x equals 25 to the power x, then find x. Usually, this type of problem that involves additions of multiple bases with powers of x require rigorous numerical solutions or graphical approaches to solve them. However, for this particular problem, there's a clever arrangement of terms that helps you solve it easily. If you're up to a challenge, pause this video right here and go for it. Alright, let's jump into the solution. First, let's rewrite this expression with all its terms factorized into their prime factors. It's pretty clear that we end up with 3's and 5's arranged into the power of x. Let me indicate the 3's in red color and the 5's in blue color from this point onwards for clarity. Now, the approach I'm thinking of is to come up with a term that contains both 3 and 5 raised to the power x, so we can rewrite this equation in terms of it, hence making this solvable. Out of the 3 terms in this equation, only this term has both 3 and 5. Hence, if we divide the whole equation by this term, it should be possible to get 3 and 5 included in the other 2 terms, isn't it? Let's see how that's gonna work. Dividing the whole thing by 3 times 5 to the power x, let's cancel off the right terms and see where that leads us. Okay, we end up with a nice equation that has 2 terms with 3 and 5 included in both, and both raised to the power x. However, as you can see, the 2 of them are not the same. Let's do something about it. Consider this term. We can rewrite it using the property of multiplicative inverse, where the denominator and numerator can be swapped while making its power negative. Then you take its reciprocal, which makes the power positive. I hope I didn't baffle you. Take a second to understand it. Now, when you plug that result in, you can see that we have finally managed to reduce the equation expressed in terms of 3 over 5 raised to the power x. From this point, it's quite easy. Let's substitute as t equals 3 over 5 raised to the power x in here, and we have a nice equation in terms of t. You can multiply the whole thing by t and rearrange the terms to get a nice quadratic equation. I'll leave its solution aside, but when you solve it, these are the 2 roots you'd be getting. T equals square root of 5 minus 1 divided by 2, or t equals minus square root of 5 minus 1 divided by 2. The first root is positive while the second root is negative. But we know that t is actually 3 over 5 to the power x, which is always a positive quantity, irrespective of the value of x. Therefore, we can ignore the negative root we got and consider only the positive root. Hence, t equals square root of 5 minus 1 divided by 2. Now, equate the 2 expressions we have for t, and it's pretty straightforward after this. Get the logarithms of both sides, and then you can bring x forward, subject it, and complete the solution. X equals logarithm of square root of 5 minus 1 divided by 2 divided by logarithm of 3 divided by 5. I hope this video helped you think differently on these type of problems. Well done if you managed to come up with the solution on your own. Please show your support with a like to this video and subscribe my channel. Then goodbye till next time.